In this example from Chapter 9 of the Introduction to the Practice of Statistics, 8th edition, by Moore, McCabe, and Craig, we'll be looking at comparing conditional distributions with a chi-square test. We'll use Excel's functions to do the chi-square analysis. For this example, we have observed or actual data looking at a particular grocery store who wanted to try various treatments of music, including when no music was played, French music was played, and Italian music was played, and the related numbers of bottles of wine that were sold during each of those music treatments, including French wine, Italian wine, and other types of wine. In total, during this observed data, 99 bottles of French wine were sold, 31 bottles of Italian wine, and 113 bottles of other wine were sold, for a total of 243 bottles of wine sold during this study. In terms of music, 84 bottles of wine were sold when no music was playing, 75 bottles of wine were sold when French music was playing, and 84 bottles of wine were sold when Italian music was played. So this is our observed data. To run the chi-squared test, we need to generate expected data. And the overall null hypothesis we're going to test for this is that there is no difference in the distributions of wine purchases at this store when no music, French music, and Italian music are played. So to generate our expected table, we're going to use our row and column totals to generate what we would expect in each cell. So for our first cell here, no music and French wine, we're going to multiply our row total by our column total and divide by our overall total in cell M8. In Excel, we can use some absolute referencing to keep these cells so we can drag our formula throughout this matrix and have the appropriate calculations made for us. So we want to keep our row total in column M, so we place a $sign in front of the M. For the column totals, we want that to remain in row 8, so we're going to put a $sign in front of the 8. And we don't want the overall total to change cells, so we're going to put the $signs in front of the M and in front of the 8. So for our first cell, our expected value is 34.22 bottles of French wine being sold when no music is playing. We can drag this equation through the top row and then through the rest of the cells. So these are our expected values for each cell. One thing we can do is we can go ahead and look and see, just comparing visually the observed versus the expected value, and we'll actually look at this mathematically with the chi-square statistic for each cell. But we can see there are considerable differences in the Italian wine row, looking at both French and Italian music. So in our observed data, only one bottle of Italian wine was sold while French music was playing, and we'd expect 9.57 bottles. And in our observed data, 19 bottles of Italian wine were sold while Italian music was playing, where our expected value was 10.72 bottles. So next, let's calculate our chi-square statistic for each cell. And our equation for our individual chi-square statistics is our observed value minus our expected value, and we're going to square that difference and then divide by our expected value. So our first chi-square statistic is 0.52, and we can drag this through our table, and we see, as expected, for our Italian wine with French and Italian music, we have the largest chi-square statistics, which represent that we had the largest difference between observed and expected values. Our total chi-square statistic for this test is the sum of all of our individual ChiSquare statistics. So our overall chi-square is 18.28. Our degrees of freedom for a chi-square is the number of rows minus 1 multiplied by the number of columns minus 1. So we have 3 minus 1 multiplied by 3 minus 1, which is 2 times 2, or 4 degrees of freedom. And in Excel, we can directly calculate the p-value. So we could have used the 18.28 and use a lookup table to determine the appropriate p-value, but Excel with the function CHISQ.test will allow us to directly input our actual range and then use a comma and then put in our expected range to calculate our p-value. This is a very small p-value, so that gives us convincing evidence to reject the null hypothesis. So this supports the conclusion that there is a difference in the distribution of wine purchases when no music, French music, or an Italian music are played at this grocery store. There's a link to this Excel file in the description below. Feel free to open it and you can delete out the values in the blue cells and recreate this on your own.